Here is another set of knowledge-based questions. Normally you'll find these questions 1 mark each in the test paper. Now they help you to review the whole concept, and here we have 3 questions. Question number 10. What is the degree and leading coefficient of f of x equals to minus x plus 5x squared minus 6x cubed plus 10? Now for each question, once you see the question, you should stop the video. Think about the answer and then move on, and I'll give you the solutions which you can check later. Okay. Now here is the solution for this question number 10. Now what we have done here is mixed up the terms. So look carefully. Normally in any polynomial equation, the leading term with the leading coefficient is written first. Therefore most of the students go for the first term. But this is like a caution to you. In test papers, when the question is so simple as that, to find the degree and leading coefficient, then the term can be mixed up in between. So you have to look carefully. Now here, as you can see, the term with highest degree is right here, minus 6x cubed. Now, first identify the term. Second, write down the degree and the leading coefficient. I've also seen students just writing one of the answers, not both. Okay, now what is the degree? So we say degree is how much? Degree is 3, right? So we say degree equals to 3. And what is the leading coefficient? Let me write an for leading coefficient. Leading coefficient is, don't forget to write minus. Okay, leading coefficient is not just 6, it is minus 6. Otherwise it is wrong. Correct? Okay, now question 11. What is the end behavior of f of x equals to minus 5x to the power of 7 plus 3x cubed plus 1? Okay, you can answer the question and then look for my solution. As I see this, what is the degree? The degree is odd. If the degree is odd, then what kind of behavior do you expect? Can you tell me? For an odd degree, we have opposite ends, right? Okay, that's first thing. But before that, what you need to see is leading coefficient. If the leading coefficient is positive, right side up. The rule is my rule. If the leading coefficient is positive, right side up. But here it is negative. Therefore, right side is down. That's what I mean. Now, if it is odd degree, opposite ends, opposite ends. There you are. So now you can write the end behavior of this. So what is the end behavior? Always write x approaches minus infinity first and then plus infinity. Because you see the graphs from left to right. It makes sense, right? So right, I'm not saying that is wrong or right, but it's a better way of doing things, okay? When x approaches negative infinity, y approaches, you see that, correct? Positive infinity. There was no need to write positive, but it's not bad, okay? When x approaches positive infinity, you're saying y approaches negative infinity, correct? So that's how you should be answering it. Question 12. How many turning points will the polynomial function f of x equals to x times x minus 1 squared, x plus 2 cubed, x plus 4 to the power of 4 have? There could be any polynomial here in the factored form for you in the test. Idea here is to teach you how to do any such factored form polynomial and find its turning points. Okay. One solution is you can sketch the polynomial. Perfect. Once you sketch it, you can see and count count correctly the number of turning points. That is one solution, right? Let me give you that solution first, and then I will also tell you the formula by which you can do it. That will be great. Okay, especially for such questions, it gives you huge understanding of the whole subject and advantage over others who don't know those kinds of formulas, right? Now Here we'll try to sketch it. So we have roots at 0, that is 1, that's at 0, and the degree is 1. See, x minus 1 is the root at 1 with double multiplicity, right? So at 1, I have 2 multiplicity. I'm just writing 2 here. It helps me, okay? I'll show you how. This one is at minus 2. So if I'm taking, let's say this is minus 2 for me. Multiplicity or the order is 3 for me. So I'm just writing for my reference. It's my rough work, okay? In minus 4, degree or multiplicity is, we normally say order or multiplicity, okay, is 4. So we got our zeros on the graph, right? Now let's count degree. 4, 3, 7, 2, 9, and 1, 10. 10 is the degree, right? So we say degree is 10. That means it is even. And an is positive. You can see that. If I multiply all these x's, right, I'm going to get positive. So it is even degree. First thing is this is positive. Positive means right side up, correct? I'm repeating this principle for you so that you get it, right? Even means both same sides. So that's my end behavior. Do you see that? That's my end behavior, correct? Now I will teach you how to sketch it so easily. Now since it is degree 4, even degree, it is going to turn, bounce back. So here we are starting from left to right. So we are coming from infinity, right? Plus. So we are going to bounce back here. This is cubic, so here it will go like this. This is linear, it will go like a line. And here again it will bounce back. Do you see? It's going back in the right direction. Do you see that? Now the only thing is I'm just going to join my graph, okay? Do you see that? That is my graph. Here these things are not turning points. Just like you understand? We call it point of inflection. It is just changing concavity. Let me show you this in slightly bigger form. Concavity is like this here and then goes like this here. So concave down, concave up, and that point is not a turning point. It is only point of inflection, never counted as a turning point. Now, where are your turning points? Your turning points are here. 1, correct? 2, 3, 4, and 5. These are your turning points, okay? 1, 2, 3, 4, and 5. So you got your answer, and the answer is number of turning points is the number of turning points equals to 5 for us. As I promised, I'll give you a formula here, okay? It's unique, beautiful formula. Okay, first count the number of zeros. How many zeros do we have? 1, 2, 3, 4. So it's a number of zeros. The formula is number of zeros, which is 4, right? Minus 1. That is first part of the formula. Number of zeros minus 1. Okay, this is first part. Why? If there are 2 zeros, right? Then you go like this, you turn once. Do you see that? There's another 0. Again turn, because you have to get to the 0, right? Another 0, again turn. So number of zeros minus 1 is always a turning point. But then there is some complication because of this order or multiplicity of our zeros. They force you to turn at times. These are additional terms, right? Here, I was not supposed to turn if this was not even, right? I should have just crossed it. Correct? Now this forced us to turn, and therefore we say plus number of even zeros. So how many even zeros do we have? 1 and 1. Don't count them as 2 and 4. Number of zeros are only 1 and 1. There are total 4 in all, right? Out of which 2 are even. So we'll add 2. Now do your math. 4 minus 1 is 3, right? 3 plus 2 is 5. You get the same answer without even sketching, thinking, nothing, right? This is basic concept. Number of zeros minus 1 is number of turning points, but additional turning points are caused because of even zeros. They make you turn at that point. I hope you understand this concept. You're not going to get all this in the books, right? And I don't think people are going to take pains to make you understand this in this era. Okay, go through it once again. Try to understand how we got answers. They may be just 1 mark each, but that's so important to get 100%. Thanks. All the best.